So the goal of this video is to go over and prepare and study for our math unit test that's coming up. So feel free to have your study guide with you. You can pause and resume the video at your leisure. I'm just going to start from the beginning and then we're going to work our way down. So the first part of this is a two-part question and it's fractions. It says write an equation to show a sum of unit fractions. Now, there's only one way you can do that because if you notice it says unit fractions here. And you know a unit fraction is one unit or one piece of your fraction. So because it's telling me 3/7, one unit of that would be 1/7. Okay. So to show this as a sum means to add. I have to do 1/7 plus 1/7 plus 1/7. Okay. And that equals 3/7. Okay. The next part says to decompose each fraction in two different ways. You have to write an equation to show the sum of fractions, and they have to have the same denominator, okay? So there are different ways that you can do this. I'm just going to show you a couple, and then we're going to move on. Now, you don't have to use unit fractions when you're decomposing these, but that's always an option. So I could do 1/10 plus 1/10 plus 1/10 plus 1/10 plus 1/10, or I could break it up. I could do 3/10 and 3/10. And that's because 3/10 plus 3/10 is still equal to 6/10. If you want it to be, different, you could do something different like 4/10 plus 2/10. That equals 6/10, or you could do one, like I said, the 1/10 plus 1/10 plus 1/10, on and on until you have your six. Okay. The next one is a little bit fun, okay, because it's a mixed number. And when we start to decompose mixed numbers, there's a plethora of ways we can do that. You can break it up the whole and then the fraction. You can break the whole up into other unit fractions. So there's different ways. I'm just going to show you a couple, okay? So because I have a whole and a fraction, which is our mixed number, I can do it as one whole plus 1/3 or 1/3, or I can just write the 2/3, or I could show this one whole as a fraction. And since it's thirds, one whole as thirds would be 3/3. So 3/3 plus 2/3 is equal to 7/3. Now, oh, I'm sorry, 5/3. Now, 5/3 is the same thing as one whole and 2/3. So that's another way you can do that. Now, this next one is patterns, and we talked about patterns before, and there's different ways you can do this. So we don't have to use the geometry template. You can just draw the shape. It's a square, and it says this square is going to represent 1/4. So show the whole. Then it says to write an equation to show your answer. So since this square is going to be a fourth, that means if I need a whole, I need 4/4. So I can do this one square or 1/4. Two squares is 2/4. Three squares is 3/4. And then four squares is 4/4. Now, if you're artistic like me, you can draw your big square and then just break up your square into four smaller squares. That still shows your four squares. Now, your equation, again, you can do this different ways. I can do 1/4. Well, really, I'm just going to do it in units. 1/4 plus 1/4 plus 1/4 plus 1/4 plus 1/4 is equal to 4/4, which is equal to one whole. Okay. Now remember, you can stop, pause the video, because we're going to go to the next question if you want to try to work it out on your own. But this next one, it's a word problem, and it says it's fractions again, and we can use manipulatives, we can use a drawing, or we can just use numbers to model our thinking. It says Chase, Nina, and Clara are shared a bowl of cereal, which is not realistic, but Chase ate 1/5 of the cereal. Nina ate 3/5 of the cereal, and Clara ate 1/5 of the cereal. How much cereal did they eat? So, to show this as a number model, I've got 1/5, and I need to add the 3/5 for Nina. That's Chase, Nina, and then I need to add another 1/5 for Clara. Now it says how much did they eat. This is showing pretty much how much they ate. I'm gonna add them together. Does it say with an unknown? Yes, it does. And because it says unknown, we're going to use a variable. Again, I don't care what letters you use, just try to stay away from X and Y. But for this problem, I'm going to use C for cereal. That's my unknown or my variable. Now I can solve it. Now I can do a drawing. I can just go ahead and use my math strategies. So this could look differently depending on the person. So if I wanted to do a drawing, the first thing that I could do is I could draw my bowl of cereal, and I can split my cereal up into 5 equal pieces. Now I can go ahead and start shading them in. So Chase, he ate 1/5. Change the color here. Nina ate 3/5. One, two, three. And then Clara, I'm going to change the color again, ate 1/5. Okay. Now, how many fifths of my shape altogether? Well, when I look at it, that is one, two, three, four, five out of my 5 total pieces, and that is equal to a whole. I'm going to write it differently. So 1/5 plus 3/5 plus another 1/5 is equal to 5/5, which is equal to one whole. So they ate one bowl of cereal, or you can write 5/5 of the bowl of cereal. Okay, remember you can stop and pause the video before we go to the next question. All right, so number 4. Mr. Jenkins used 2 3/6 cups of sugar to make cookies. Miss Marshall used 2 2/6 cups. How much sugar did they use altogether? So if you notice it says together, that is a clue word that lets me know I need to add or combine them somehow. My numbers or my cups of sugar are 2 and 3/6, and then 2 and 2/6. So my equation or my number model is 2 and 3/6 plus 2 and 2/6. Now, if you notice it says number model with unknown, I need another variable. So for this problem, I don't care what letter you use, but for me, because they're talking about sugar, I think I'm going to use the letter S for sugar. Now, when you're adding mixed numbers, guys, you can add them just like regular numbers. I like to stack them up and then add them up. So I'm going to get my 2 and 3/6. Notice I'm making my whole number bigger than my fraction, and I'm going to stack 2 and 2/6 on top of that, and then I can add. So 3/6 plus 2/6 is 5/6. Good. And then my whole numbers are 2 holes and 2 holes. 2 holes and 2 holes equal 4 holes. So my answer is 4 and 5/6. And I can't reduce that 5/6 any further. That's as low as I can get. Okay. If you need to pause the video to write this down or change anything, you can do that now. Let's go ahead and look at the next problem. We are adding. You can use drawings or models to show your thinking. So I'm gonna add up my all of these fractions. I'm gonna start with A, 2/4 plus 1/4. Okay, 2 plus 1 is 3. Don't forget to keep your denominator the same. Okay. The next one, 6/10 plus 5/10. All right, this one's going to be different, okay? So 6 plus 5 is going to be 11/10. Now you look at this fraction, 11 over 10. That's an improper fraction. It's an improper fraction because I have the large number on the top. My numerator is larger than my denominator. That means I have more pieces or more than a whole. I have more pieces than I have in one whole. So in order to do this, there's different ways we can draw it out. You can draw out your 10 tenths, which is your whole. That's 10 tenths. Now, if you take 10 tenths and you need 11 tenths, that means I need one more tenth. And that's what it would look like. One whole, or my 10 tenths, plus my 1/10 if you were to decompose it. So one whole and 1/10 is your answer for that one. We changed our improper fraction to a mixed number. And this last one, this one's also different. I've got 5 wholes plus one whole and 1/4. Well, just like what we did on number 4, where we stacked them and added them, I'm going to do the same thing. I'm going to stack them up and add them up. So I'm going to stack up my 5 wholes on top of my one whole and 1/4. Well, if you notice, I don't have any fractions beside my 5 wholes. So I have no fourths plus 1/4. So no wholes plus 1/4 is just 1/4. Now just add up your whole numbers. 5 wholes plus one whole is equal to 6 wholes. And that's my answer, 6 wholes and 1/4. If you need to pause the video, you can pause before we go to the next question. The next one is also adding. If you look at it, I've got bigger numbers. Now, when we talked about decimals, it's kind of the same thing. We've got tenths and hundredths, which you know are decimals. So 5 tenths plus 40 hundredths would look something like this. Now, when we have problems like this, remember your strategy is to add a zero to make sure you have the same amount of number or the same amount of digits. Okay. So look at my number now. 50 hundredths plus 40 hundredths. Well, 50 plus 40, or 50 hundredths plus 40 hundredths, 50 plus 40, 5 plus 4 is 9. Add your zero. That's 90. And I'm going to put it over my hundreds. Now, some of you like to be fancy, you like to reduce it. If you want to reduce it, you could also do that. I'm fine with that. Reduce it to 9 tenths. It still represents the same amount. Okay. Now, after you write that down, if you need to pause, do so, but we're going to go ahead and go to the next question. So let's read it together. The next question says that during PE class, Lucy drank 3/6 of a liter of water, but Dominic drank 5/6 of a liter. How much more water did Dominic drink than Lucy? So let's look at this problem. All right. So I see, or look at what I know. I know that Lucy drank 3/6 of a liter of water. Dominic drank 5/6 of a liter of water. But look at our keywords. How much more water did Dominic drink than Lucy? Hmm. How much more is a clue word that means subtraction. So I'm going to subtract. So I'm going to start with my bigger fraction, which is 5/6. So Dominic drank the most. 5/6 minus Lucy's 3/6. So 5/6 minus 3/6. And our problem says to write a number model with an unknown. And since we're drinking water, I'm going to use W. So now I need to figure out 5/6 minus 3/6. You can use models to draw it out, or you can use your numbers if you'd like, as long as you're using some type of strategy. So here's my whole, and I'm going to split it up into 6 equal pieces. I am going to start off with 5/6. 1, 2, 3, 4, 5. And I'm going to cross out or take away 3 of them. So cross that one out, cross that one out, and cross that one out. Look at what I have left. I've got 2 of the fifths left over. So when you go to write your answer, my answer, 5 minus 3, is 2/6 of a liter. Okay. Let's look at the next question. It's another fraction problem. So this problem says that Mac lives 5 1/3 blocks away from the library. He also lives 2 2/3 blocks away from the school. How much farther does Mac live from the library than the school? So let's think about this problem before we try to start solving. So I know Mac lives this far away from the library and this far away from the school. But the question says, how much further does he live from the library than the school? How much further is just like how much more. You're comparing these two mixed numbers. Since I'm comparing them, comparing is another word for subtraction. So since I'm comparing them or contrasting, trying to find the difference between them, I'm going to subtract my 5 and 1/3 from, oh, I'm sorry, I'm going to subtract my 2 and 2/3 from my 5 and 1/3. And our problem says number model with an unknown. My unknown, let's use, oh, this one's different. Let's use D. And I'm going to use that for distance. Okay, D for distance. So when I'm subtracting mixed numbers, you can do models, you can stack them up and subtract them up. So there's a plethora of strategies that you can use. I don't care which one you use as long as you're comfortable with it and as long as it helps you out. So for this problem, I'm actually going to do it differently. I'm going to go ahead and model it, okay? So I'm going to use squares to model my 5 and 1/3. Okay. There's my 5. And I need another shape for my 1/3. Split it up into thirds. And then I can go ahead and shade them in. Okay. So shade in my 1, 2, 3, 4, 5. And I need to shade in one of those thirds. Now that I've shaded in my fractions, I can go ahead and start getting rid of my 2 and 3/3. So I'm going to cross out my two holes, get rid of those. And I can get rid of this 1/3 from my, because I got to take away 2/3. But my problem here is I'm out of thirds to take away. So here's what we're going to have to do. We're going to have to do some regrouping. And when we regroup fractions, we're going to have to break up our whole or borrow a whole, convert it into thirds like that, and then we can take away another third. So I converted my one whole. I had three left. I'm going to take one away, change it into thirds, which is just 3/3. And now I can go ahead and cross out the 1/3 that I need left. So cross that out. And that leaves me with 2/3 left and two wholes. So my answer, if I'm looking at this model, is two wholes and 2/3 blocks difference between the library and the school. Okay, if you need to pause the video to write this down before we go to the next part, you can do so now. Now, this next question we're subtracting fractions now, and this is very similar to adding fractions. If you can add fractions, then we can subtract fractions. So 4/5 minus 1/5, well, 4 minus 1 is 3. Don't forget to keep your denominator the same, okay? Now look at the next one. 6/10 minus 2/10. Okay, 6 minus 2 tenths. 6 minus 2 is 4. Don't forget to keep your denominator the same. Now C, again, we've got mixed numbers. So this is different than A and B. What you notice, they're going to throw in some harder numbers. Again, we have strategies. We can draw it out. But for this one, let's try to stack them up and then subtract them up. So I'm going to take my 8, I'm going to write on the side where I got some room, and 5/12 minus my 5 and 7/12. And we could subtract. On our last problem, we had to do some regrouping, right? Look at this problem. 5/12 minus 7/12. Can I take 7 away from 5? Nope. So let's go ahead and borrow, okay? I'm going to borrow one whole from my 8. That 8's going to become a 7. Now that one whole that I'm borrowing, I'm going to write it as, or I'm going to convert it to a fraction. That is going to be 12/12 because 12/12 is a whole. Now I've got 12/12, my whole that I borrowed, plus that 5/12. That's going to be 12 plus 5, 5 plus 2 is 7. That's going to be 17/12. Now 17/12, I can now take away my 7/12 from 17/12. So 17 minus 7 is equal to 10/12. And now 7 minus 5 is 2. So my answer here is 2 and 10 twelfths, okay? 2 and 10 twelfths. All right. We're going to go ahead and go to the next problem. The next problem are line plots. And this is what we recently did. So you notice we're going to be reviewing this week. And so a lot of this stuff is going to start making, more sense because we did it most, more recent than the other problems. Okay. It says to use this data table to create a line plot and then answer the questions below. The problem says that Miss J's class measured their ears to the nearest half centimeter. The measurements they gathered were shown down here. You see, you have some numbers that are repeating. So it looks like the class measured their ears. In our class, we actually had the chance to measure their circumference of our head, and then we made a line plot that way. But this class did something different. So let's go ahead and title it. The title of this line plot that we're gonna make, we're gonna call it Miss J's class ear size, or we can just say ears. How about that? Make it simple. That's our title. And we also need to label at the bottom. So the smallest number that I have here is one whole. Okay, so I'm going to start with my one whole. My next would be, I have, since I'm measuring to the nearest, if you remember, to the nearest half inch, or I'm sorry, half centimeter. So I'm going to write one, and then I'm going to go to the half centimeter. So that would be one and a half. The next one would be two, even if it's not up there, we still have to write it down. So we go in order. Then two and a half, then three, and then we're going to stop at three and a half. Okay, this is our label. Now, what we're doing is we're labeling the ear sizes in centimeters. So I'm going to put ear length at the bottom for my label in, and I'm going to use cm for centimeters. Okay. Now that I've labeled it like this, make sure you have that, and you start at one and end at three and a half because that's just how far it went. I'm going to go through, I'm going to put an X on my line plot to show the data, and then I'm going to cross it out when I'm done. My first number is one and one and a half. Let's put an X on the one and one and a half, like that. I have another 1 and 1 centimeter and a half. Put an X. I have one, put an X. I have another one, gonna put an X. I have one, two and a half, right here, put an X. Another two and a half, put another X. Another two and a half, put an X. Got a lot of two and a halves here. Another two and a half, put an X, and I'm crossing them out so I don't get mixed up. And then I have one more two and a half. Wow, look at that. And then I have one, three. Okay, so put an X on three. So here's what your line plot looks like. If you need to pause it to catch up, you can do that. Now let's answer the questions since we have our line plot completed. Make a line plot. We've done that. Check. What is the longest ear? Okay, what length is the longest ear? So look at my X's. I have one X on 3 centimeters. So that's 3 centimeters. C says what length is the shortest ear? That's the smallest. So if I look at my one, I have two X's or two ears that measure 1 centimeter. Okay. And the last one says, what is the difference in the length between the longest and shortest ear? So with this problem, it says the difference. Difference is another clue word. That means subtraction. Write a number model to show our solution. So we're going to take the longest and the shortest, and then we're going to find the difference, which just means subtract. The longest is 3. The shortest is 1. So 3 minus 1 is 4. That's my equation. My answer is 4 centimeters. All right. Once you do that, this problem right here should say unknown, but I didn't do that. So let's go back. I apologize. We're going to go back and we are going to use an unknown. So I'll have to fix that, okay? 3 minus the 1 equals, and let's use E for ears. Okay, that's our unknown. Now our answer, our E is going to equal to 4 because, I'm sorry, is going to equal to 2 because 3 minus 1 is 2. Sorry, I'm writing the wrong thing. Okay, so 3 minus 1, that's our number model. Our variable is E or our unknown. And then our answer is 2. Once we do that, we're going to go ahead and go to the next question. We're going to go to angles, which is recent, something we just did. So this problem says draw the pictures using the turns. Make sure you use an arc. An arc is the arrow that shows which way the angle is opening up to show the direction. The vertex of the angle and one side have already been drawn for us. This question says a 3/4 turn clockwise. Since we're going clockwise, we need to go to, like the way a clock moves, to the right, like this. Now I'm making a 3/4 turn, and I know 1/4 is 90 degrees, 2/4 is 180, 3/4 would look like this. But look at my arc. It's going that way to show that it passed 3 sections of our circle. Letter B says make a half turn. Oh, and we're also going clockwise. Y'all, I made another mistake. I'm reading that wrong. This is clockwise, but A is counterclockwise. I'm sorry, but since I'm making a video, I can't really delete what I just said. So let's go ahead and just fix it. We're gonna fix it, okay? Counterclockwise is going to the left, okay? So let's redraw this to the left like that. All right, now that I've drawn it to the left, I'm going to do my half turn, but I'm going to do it clockwise. So I'm going to go this way. So a half turn is 2/4 turns. So that's like 90 degrees, and another 90 degrees would be 180. And look at this. I just made a straight angle. All right, let's look at the next part. Number 12 says estimate the size of the angle and then circle the best answer for it. Okay. Now, this one is easy because you guys know your acute, right, obtuse, and reflex angles. So I'm looking at angle ABC. Is it acute, obtuse, or right? Yep, this is an obtuse angle because it's more than 90 degrees. So I'm going to go ahead and write obtuse. And then does that mean 0 to 90 degrees? Is it exactly 90 degrees? Or is it between 90 and 180 degrees? I'm going to circle between 90 and 180 degrees. And that's my answer. Once you write that down, if you need to pause the video to catch up, you can. But number 14, this is very recent. These are more things that we've done recently this week. It says draw all the lines of symmetry for the shapes that are symmetrical. So that means, a shape, any of these shapes could be symmetrical or they could not be symmetrical. It just depends. I'm not going to tell you. So on the test, you could see symmetrical or you could see non-symmetrical shapes. But if the shape is not symmetrical, all you have to do is write none. Okay. So let's look at this shape. So if I were to fold this and mirror it, would it be the same on each side? Well, if I folded it this way, yes, because there's a long edge here and a long edge here, I could do that. But this shape actually has multiple lines of symmetry. I could also fold it halfway that way as well, because again, long side, short side, and long side. So if I fold it over like a piece of paper, it would actually match. Now, this one also has multiple lines of symmetry. Guys, if you want to get fancy, think about it this way. What if you fold it diagonally? Would this edge match up with that side? Yeah, it would. So there are a total of 6 lines of symmetry for this shape. Now, let's look at B. B is special. One trick that we did in class is we held our paper up to the light and we tried to fold it to see if it works. Now, if I were to fold this shape, I know a lot of you are thinking, well, Mr. Jenkins, can we fold it in half? No, we couldn't fold it in half because if we did that, you would see that one side would be shorter than the other side. All right, so that wouldn't work. But what if I try to fold it diagonally? I know some of you are like, Ms. Jenkins, that has to work because they both have points on opposite sides. But because it's slanted, one side is going a different direction than the other side. So even if you tried to fold it diagonally, either way, it would not work. So this shape is special because it has no lines of symmetry. So I'm gonna write none for no lines of symmetry. Now letter C, we have a triangle. Now triangles are cool. Now what kind of triangle is this? If you were to measure it, you would see that these sides are all equal. This is an equilateral triangle. Because it's an equilateral triangle, I can fold this triangle in half, going from the point to the flat side. But if you notice, if I have 3 points in my triangle, I could go from this side to the flat side, and I can go from this point to that flat side. So triangles or equilateral triangles, which have three equal sides, actually have three lines of symmetry. So there are three lines of symmetry for letter C. If you need to pause the video to write that down, you can. If not, let's move on. Number 15, we have more symmetry. So we're going to use these dots as a grid. Now I have a point here and there, and I'm going to try to connect these dots to make sure I mirror this image on this line. So I'm going to pretend it's folded, and then when I open it up, what would it look like? So this part right here, it looks to me like half of a rectangle. So I'm going to go ahead and complete my rectangle. Up here, this looks like from this point to the very top, which is on the line, looks kind of like half a triangle. So if I close it and make a complete triangle, that's what it'll look like. And the same thing on the bottom. I have this point here, and I want to go ahead and close it. So this is what your complete shape would look like. You just have to make sure if it looks the same on both sides. That's why it's called symmetry, because they mirror or show a reflection of the other side. Once you write that down and you have your drawing, let's go ahead and go to the next question. This is actually our last question. We are almost done, guys, okay? So our last question here is a word problem, okay? So we're going to read it carefully. We're going to write a number model with an unknown. Then we're going to solve it and we're going to answer it, okay? Two brothers each want to buy a science kit and a scale to go with it. Together they have $62. And if each science kit costs $13 and each scale costs $8, how much money will the brothers have left over after they purchase all their items? So before when we do word problems, I always ask you to read it a couple times if you don't understand what it says. Then after you read it, we can go ahead and look at what information we know and then look at what we need to figure out and make a plan. So one thing that I noticed, I see there are two brothers. Is that important information? Not really, not for this problem. Because they're sharing the money, they're buying it for themselves, so it doesn't matter that there are two of them. But what I do notice is they have a total of $62. Okay, that's important. A total of $62 that they're going to spend on science kits and scales. So the science kit is $13. The scale is $8. So they're going to buy a science kit and a scale. So when you go to ring it up, that's the $13 plus the $8, right? Simple. But then, how much money will they have left over? Ooh, left over after they purchase these items. Wow. So they have $62. They're going to spend it on the kit and the scale. So I'm actually going to group those together. And then because it says leftover, I'm going to subtract it from the total money. So 13 and 8, we can add our money together. We can add the items, the cost of the items together, and then take it away from our total. And don't forget to use an unknown. Let's use I don't care what you use. I'm probably gonna use M for money. So I need to figure this out. Parentheses tell us what to do first. So I am going to solve it by doing 13 plus 8. So 13 plus 8 is going to be 21 because 8 plus 3 is 11. Carry our 1, that's 21. Now I can go ahead and subtract my 21 from my $62, okay? Now 2 minus 1 is 1. 60 minus 20 is 40. So they should have $41 left over. M is equal to 41. And then don't forget your units because that's very important to have units with a problem, right? $41. I put the dollar symbol over my in front of my money. And that's it, boys and girls. So please make sure you study this. If you need to go back and rewatch it, you can, okay? Good luck.